All right. Hi, Green Group. I'm going to help you through activity two. So if you had a hard time, this should help you get through the work. What we're going to do is take a look at the images of the sodium and the hydrogen chloride before they were mixed together and after they were mixed together. So we're going to look at the reactants, what we started with, and the products, what we ended up with. We're going to make some observations and answer a few questions together. Remember that different substances have different properties. That's going to be important on this first page. All right, so here are the reactants. We had sodium, okay, and when I look at sodium, I can see that it's a solid, it's shiny, and it's a silver color. Hydrogen chloride is a liquid, it's transparent, which means you can see through it, and it's colorless. And after these two reactants were combined, this is what happened to the results. So the results, I can say that I kind of have like a white color. It appears that it's a liquid and it looks cloudy. So if I go down, my observations of sodium were that it was silver, solid, and shiny. And you're more than welcome to pause the video at any point if you need to go back in and type these things in to amplify. The hydrogen chloride was colorless, liquid, and transparent. And the results were white, liquid, and cloudy. Now, based on those properties that I observed, in my mind, I'm going to make the prediction that there were three substances. And the reason why I did that was up at the top, we talked about different substances have different properties. None of these three substances had all of the same properties. If they did, they would have been the same substance, but they all had different properties. Therefore, I'm going to make the prediction that there are three substances involved in the video. My observation or my explanation about those observations would be that the properties of the results are different from both those of sodium and hydrogen chloride. The results had different properties than the two substances that I mixed together, and that's why I made the prediction that I did. So if you need to, pause the video, rewind. Okay, I'm just trying to help you out. And you can go back and you can get this information put into Amplify before you go on to the next page. All right, on the second page, we're going to look at the atomic scale, and we know that we couldn't see the atoms because they're so small that make up those substances in the video. So what we're going to do is look at the atomic scale models of each of the substances, and it might give us more evidence about how many substances were actually involved in the video. Remember that substances have different properties because they're made of different groups of atoms, and they can be a different type of atom or different numbers of atoms that make up those groups, and that groups of atoms repeat to make up a substance. So a glass of water would have many molecules of H2O. It wouldn't just be one or two that make up a glass of water. We're talking about bajillions of atoms. All right, so with the pictures now we have the atomic models. And what I can tell when I look at the atomic models is that there are three atoms in total that are involved in the demonstration in the video. We have sodium, chlorine, and hydrogen. There are different repeating groups of atoms. Sodium is made only of sodium atoms. Hydrogen chloride is made of hydrogen and chlorine atoms. But, and this is the big aha moment, the results were not actually one substance, it was actually two substances mixed together. So we had hydrogen, two hydrogen atoms connected together that made a new substance, and we had a sodium and a chlorine that rearranged and formed what's called sodium chloride. So based on what I just saw, I'm now going to change my prediction and say that there's more than three substances that are involved in Lee's experiment in the video. And my answer for that would be, I can tell from the atomic scale models that there's four substances because the model shows the repeating groups of atoms that make up the substances. Okay, as these repeating groups of atoms are every one of them is different, the substances have to be different. So I had four different repeating sets of atoms, which gave me some evidence that I didn't have just three substances, but I had four substances involved in this this demonstration that Lee did in the video. All right, page 3. We're going to go into the sim, and we're going to observe what happens now when we put these two reactants together, the sodium and the hydrogen chloride. So we're going to launch the sim. We're going to go to laboratory A mode. We're going to add the substances, and we're going to kind of watch what happens to those substances. Remember that during a chemical reaction, atoms don't change from one type to another. And remember that during a chemical reaction, atoms rearrange to form different groups of atoms if there's a chemical reaction. Okay, so we're going to go in to the sim, and we're going to add our sodium, and we're going to add our hydrogen chloride, and we're going to test this by putting them together in the sim and watching what happens at an atomic level. All right, I'm going to replay this, and I'm going to find the place where there was a little bit of evidence that a chemical reaction took place. And to me, that place was right here. You can see that this chlorine stole one of the hydrogens from the two hydrogens. I'm sorry. There was a rearrangement. When we started, we had sodiums by themselves. And as we played this right there, a sodium stole a chlorine from the hydrogen. That is what a chemical reaction is. So if we go to the results, and review this and turn on the atomic scale and turn on the property scale, you can see, if you take a second, that all of these substances have a different property than the other ones, which mean they're all the same. They're all different substances. And you can also tell that their arrangement of atoms is different, which gives us more evidence that we've got 4 different substances, 2 reactants and 2 products, what we started with, what we ended with, after what's now becoming pretty clear that we have a chemical reaction that took place. All right, so I'm going to go down to the bottom, and how did the sodium and the hydrogen chloride change into 2 different substances? It was the rearrangement of the atoms. We saw that the sodium atom tore the chlorine atom from the hydrogen, took its place, and it left the hydrogen out by itself. So there's not anything else you need to do for that. You can just press next. All right, finally on the last page, what we're going to do is use those tokens to rebuild and take a look at how all of this rearranging happened in more detail. So when we put the tokens together, we've got to have 2 sodiums, and we have to have 2 repeating groups of a hydrogen and chlorine. We're going to go back into the agenda, and we're going to open up the token modeling tool. And in the modeling tool, what we're going to be able to do is put our reactants. So this is our sodium, which is that shiny metal. And we need to put together 2 repeating groups of hydrogen and chlorine. And this is just another way to look at what happened in the sim very, very quickly. We know that now there was a chemical reaction that took place. And we saw that the sodium and the chlorine rearranged to make sodium chloride. And we also saw that the hydrogen rearranged, and it became 2 hydrogen atoms that were connected together. So all of the atoms stayed the same type. We didn't change sodium into oxygen or nitrogen or iron or anything. And we still have exactly what we started with on the product side. So going back, what we're going to want to do is we're going to want to answer this question: how did sodium and hydrogen chloride change into 2 different substances? I wrote down that the sodium and hydrogen chloride changed into 2 different substances due to a chemical reaction. When they were mixed together, the atoms from the hydrogen chloride and sodium atoms rearranged to form different groups of atoms. 2 different groups of atoms formed, therefore there were 2 different substances formed. Once again, you can pause the video and you can take a look at this and type it into your own activity if you want to. Sorry, my dog has an issue with people walking around outside. All right, hopefully this helped you out. You can go back and look at any of it that you want to. Thanks for tuning in, and I hope this makes more sense.